Hi kids. So from the first video that we have learned these two bullets here. How to identify the prime numbers and composite numbers and express composite number as a product of its prime factors. This time we're going to look into the following. But before that one, let's try to review, okay? Let's try to review the prime factorization. So again, as you watch this video, I want you to open your book, okay? The one that I'm teaching you now are the core skills that you need, so you would be able to answer your book independently. Okay, let's try to do this as a review. Express 126 as the product of its prime factors, right? So you have there 126 as a product of its prime factors. Again, what do you need to do? You can divide this successively. That's divisible by, again, you just need to think of the prime numbers 2, 3, 5, 7, 11, 13, 17. Okay, which of these numbers can divide 1 to 6? 2 can divide 1 to 6. So therefore, this 12 divided by 2 is 6. 6 divided by 2 is 3. Which of these number can divide 63? 3 can divide 63. So 3, that is 2. 6 divided by 3 is 2. 3 divided by 3 is 1. 21. Which of these number can divide 21? Well, 3. So you have there 3, and then this one will give you 7. Which of this number can divide 7? 7, which is already a prime. So therefore, you stop. So 126 is actually equal to 2 times 3 times 3 times 7. Okay, so that's actually the answer. Or you can do prime factorization 3. So for example, prime factor is 3. 1 to 6 can be divisible by, you can have it, anything will be fine actually. So for example, you can have it, let's say 2 and 63. But 63 is equal to 9 and 7. Okay, but 9 and 7, this is already a prime. You can continue with this, that is 3 and 3. So you stop if you have already the prime numbers. So then you have 2 times 3 times 3 times 7. Okay, but for me, the easiest one is this. So if I were you, I'm going to use this method and not this method, except if in the examination, I ask you to use this method, the prime factor tree. Okay? Now, before we proceed to the least common multiple or highest common factor, I would like to introduce you to index notation. What do you mean by index notation? For example, 3 times 3 is 9. Okay? 3 times 3 times 3 is 27. 3 times 3 times 3 times 3 is 81. Uh-oh. This is gonna be too long if you will write the 243. Okay? So but then there is a shorthand. 3 times 3 can also be written as 3 squared. 3 squared. Take a look. 3 squared means 3 times 3. 3 cubed, meaning to say that's 3 times 3 times 3 equals 27. 3 to the fourth is equal to 81. So you just need to multiply the number according to the power, okay? According to the power there. So this is what do we call as index notation. That is an index notation, all right? Now, so what do you mean by 4 squared? It means 4 times 4 equals 16. That is the meaning of that. Okay? What do you mean by 5 cubed? 5 cubed is 5 times 5 times 5. Okay? Which is equal to 5 times 5, 25 times 5, 125. So that is the meaning. Take a look, huh? 5 raised to 3 is 5 times 5 times 5, not 5 times 3, not 5 times 3, but 5 times 5 times 5 equals 125. Therefore, why do we need to know this one? Let's try to look into this. If 126 can be written like this one is actually 3 times 3. That can be written as 3 squared or 3 to the power of 2. So this one now, 126 can be written as 2 times 3 squared times 7. Okay? So we're going to use the index notation. Let's try to look into the examples in your book. So again, in here, 2, this is read as 2 to the powers of 3 or 2 cubed. 2 cubed, all right? 2 to the power of 3. The 3 is the index, the 2 is your base, all right? I just want you to remember that if 2 to the power of 3, it has a special name, cube. 2 to the power of 2 has a special name, squared, right? Don't forget that one. So let's continue. So let's try to look into this question. Express 720 as the product of its prime factors in index notation. Okay, in index notation. So I think there is a solution here. So let's just try to look at it. Method number 1 and method number 2. Again, teacher Daniel loves method number 2. But then if you want to use method number 1, it's up to you. So you write the 720 there. It's divisible by 2. 720 divided by 2 is 360. Divided by 2 is 180. Divided by 2 is 90. But 90 is divisible by 3. So 45. 45 is divisible by 3. That's 15. Okay. 15 divided by 3 is 5. All right. Then you can stop here. Okay, or 5 divided by 5 is 1. You continue until 1 is also okay. But you can stop there also okay. Either you stop at 5 or you stop at 1. It doesn't matter. Okay, so now the answer is 2 times 2 times 2 times 3 times 5. That is this one. What is that in index notation? What is that in index notation? So as you can see here, as you can see, this one is 2 times 2 times 2 times 2. That's 4 times. That's actually 2 to the 4th. All right? And then you can have actually the next one. So 3 times 3. That is 3 squared. And then you have 5. Just simply copy the 5 there. What is now the final answer? 2 to the 4th times 3 squared times 5. That's the final answer. It's similar to this method. Okay? 2 to the 4th times 3 squared times 5. So that's what you mean by prime factorization. And that's how we write the answer in index notation. All right. So don't forget that. Don't forget that's the meaning of the index notation. So let's proceed to the next one. Okay. I think I'm gonna stop in this video because you can try to answer these questions. All right. The book is hanging. You can try to answer this question before we proceed to the highest common factor. Okay. So try to do it by yourself. And then we're gonna discuss the answers in the class. So that's what we're going to do in the class. Um, we can have videos, and then you can watch at home before coming to school. And then so when we go to school, we will just purely do a discussion. Okay? See you.